So in doing this problem, this is very similar to the one that we did yesterday, where we have a certain stock and it's growing by a certain percentage every year, and we want to know when it's worth something. And yesterday, we went through that whole process of doing that, where we made the graph and then we looked at the graph to figure out when it reached whatever value we were looking for. We're going to do the same thing with this one today, except you'll notice that there is a difference. Step one, we still write the equation. But when we go to write this particular equation, notice that gives us 100 times 1.09 to the t. And then we're going to take that information, we're going to still make a table. But notice that this one is different because of the 100. We have the 100 being multiplied. And that's going to affect our graph. And that's going to affect our graph values as well. So, in order to make the graph, I'm still going to start with the table of values. So, a nice set of values to use here are our nice easy numbers. And then I'm just going to go by fives, because it's going to be the kind of thing that's generally the most useful, is seeing what happens every 5 years. It gives us a pretty good idea about what's happening, if not perfect, when we go to make the graph and use our graph to figure out our answer.
Mr. Morgan, can you just always...
But you notice I'm not just going by fives. I also threw in a couple other numbers there, just because I expect that these should be pretty easy. The 0. If x is 0, so that's saying that this is playing the role of 0 here. What's 1.09 to the 0? 1. Remember, anything to the power of 0 is 1. And so 100 times 1 then gives me 100. So I can know that my y value is going to start out at 100. Notice that difference from what we've done previously then. All of the graphs we've made before started at 1. Now it starts at 100. That is actually going to be true of all of these, where whatever this number is that's multiplied out front, our p-value, it's our starting value. It's the starting value on the graph too. Okay, what about if it's 1? If x is 1, well, that means we're doing 100 times 1.09 to the 1. What's 1.09 to the 1?
Oh, g is the...
That's 1.09. So what's 100 times 1.09?
109.
Yep, it's 109. Those are the easy ones. Those are ones that I hope that you're going to be able to get basically just off the top of your head. But from here, it's definitely calculator work. So get out your calculator and start figuring out the rest of those y values. I chose to give 2 decimals on each of these numbers, just kind of as a matter of habit. I tend to include 2 decimals on each one, but you didn't have to as you did them. You could have even rounded these to the whole and it'd be fairly reasonable, because let's think ahead to what we're going to use these for. The next step of this process, now that we've made the table, is we're going to be making the graph. And when I go to make the graph, that means I'm going to be plotting the point 5, 153.86. Am I really going to be accurate enough to plot 153.86? No, probably not. Especially considering some of the really big numbers that we get to down here. We're in the thousands. And so because of that, when I go to make the graph, I really am just going to be focusing on the whole numbers. So really, these are the numbers I'm going to be using. These are just the rounded to the whole numbers.
What?
So now that we have the numbers, we got to make the graph. But when we go to make the graph, if I do what I did last time, if I do what I did yesterday and just go by ones on both axes, I'm going to have a problem right away. Because the very first point I need to plot is 0, 100. Which is not just off the grid, but it is way off the grid. And it just gets worse from there, right? Do we really want to have to deal with graphing grids that have over 4,000 squares in them? No, absolutely not. And so that's why we choose different scales that are going to make a little bit more sense with any given problem. Now in this particular case, I gave you x's to use that were in a nice little range to actually be able to go by ones on the x-axis. So on the x-axis, go ahead and label those just like we did yesterday. At least label the tens. You can label more if you want to, but at least by going by the tens, we make sure that we don't miscount when we go to plot some points and put in the wrong spot or something like that. It's easy to do once we get rolling. But now where the tricky part comes is labeling my y-axis. And if you actually took the moment to count up how many total squares we have on our y, there's 30 squares there. Because remember yesterday when we went just by ones, we went up to 30. So I need to now make some choices. Remember what this question originally asked. It asked us, when do we actually reach a value of 2,500? And so I know at the very least I have to include 2,500 in my graphing grid. And so just so that we all are doing it the same way, I'm going to choose some nice pretty numbers here that we can use. I'm going to go by hundreds, which means that the top of my graphing grid will then be 30 times 100. What's 30 times 100?
300. No,
3,000.
You said that?
And so you can see then this is how I need to label my y-axis. At the very least, I want to see those three numbers labeled on your y-axis: 1,000, 2,000, and 3,000.
What was 1,000 square then?
All right. And so now we actually have to start using that altered scale in plotting points. And for some people, this can be a little bit tricky, so I'm going to talk our way through as we go. If it helps you to also make sure that you're plotting these points nicely, just to remember that we're going up by hundreds, you could also write the 100 on that first increment. That way you remember that each one is 100. All right, so my very first point that I'm going to plot is at 0, 100. So that means x is 0, y is 100, so it's going to go right there at that first point. So looking like that.
No. I
Then-
don't think that's right.
The next point would be at 1 and 109. That's going to be hard to be too accurate with. It's just over 100, so I'm going to go ahead and plot it, maybe just up from 100. Because remember that I'm saying that it's between 1 and 200, because that's what those two lines are at. That's 100 and 200. Okay, so the next one needs to be at 5. Okay, so we know 5. And 154. Well, 154, remember I'm going by hundreds, so it's got to be between 1 and 200. And 154, that's about halfway between 1 and 200. So I'm going to put it about halfway between 1 and 200 there. Notice where that actually makes it end up. All right, so then next up, we go to 10 to 37. So, of course, I'm going to go over 10, but then I'm going up to 237. Now, remember, our scale is hundreds, so that's between 200 and 300 then. Which is it closer to, the 200 or the 300?
200. I mean 300. I mean 1.
Closer to the
Numbers.
200. Yeah,
It's closer to
because it's less than 250. And so I'm going to go over to 10, and I'm going to go up between 200 and 300 and kind of have it on the lower half because it's closer to the 200 side than the 300 side. And then you plot the rest of the points from the table here. This is where each of those points end up, so you can check where each of the points are. Now, if your points are looking good, and you've confirmed that they're the same as what I have here, then go ahead and draw the curve that goes through them. Now, as you take a look at the curve that I drew in, though, there's something I want to draw your attention to, because it's going to be really important to us here in a minute. This is the last point I was able to plot. It's the last point I was able to actually fit on my graphing grid. And one of the things that I'll sometimes see people do with their graphs is I'll see them really carefully go point to point, and I see them taking their time, they're doing really well, and then they get up to this last one, and they're like, and then it goes this way.
That's dumb.
That's a little bit of a problem, because we're going to need to be using this graph to predict when it hits a value of 2,500. That means we're going to be looking up here. And those are going to be very different values if we do that. And so how do we know how to make that last part somewhat accurate? Well, we can actually use the fact that even though we didn't plot it, then we have this number here. Because we know that over at 40, that it would be at 3,141. So that's going to be, I can kind of visually estimate, that's going to be like somewhere up here. Now, I'm not drawing through that point, but I kind of visualize where that is, and then I can then use that kind of as my target as I draw in my graph to help be a little bit more accurate. Just gives you that one little piece to let your graph go ahead and be as accurate as possible out there, and therefore also useful.
So if the next dot.
So now we can use this graph. Now that we've made this whole graph here, I can now use it to figure out when do we hit a value of 2,500. But where am I looking for the 2,500? Well, the scale helps. It helps clue us in. But as a matter of habit, let's go ahead and label the axes. What does the horizontal axis represent? What do all those numbers mean?
Y, X.
They're all of our x values, which is what we plugged in for t, right? It's our t values. And so, since they're the t values, that's time, which is in years. So you go time, which is in years there. And what's the vertical axis? That is, what's the y-axis? What do all these numbers represent?
Time in years.
They're money, right? It's the amount. Label your axes as you see up here. Now that we've labeled our axes, we can use that. Remember the original question was, when will this stock be worth $2,500? On your paper, I'd suggest you grab a ruler and actually hold it up to that line so it's a little easy. I'm drawing in where that ruler would be held here. It's up at 2,500. And so what we're looking for is we want to know, where is this point?
Whoa. Such zoom. You scare me.
And so you'll notice that that appears to be between, and I can always follow it down to see, it's between 37 and 38. And so if it's between 37 and 38, looks like it's closer to 37, I'd say maybe 37.2, 37.3, right in that area there. Since you already have the graph made, use it, figure out when would this stock be worth $1,200 then. And so again, remember, we hold up the ruler at 1,200. That would put your line right there. You notice that's 2 above the 1,000 mark. And so then this is my point that I'm looking for. It looks like it's actually pretty close to right on a number here. Looks to me like it's at 29. So we'd say about 29 years. Remember, it's an estimate. It's not going to be perfectly 29, but it's pretty darn close. And one last one, since we already have the graph sitting there in front of us. When would the stock be worth $2,000 then? And so you hold up your ruler so you can easily see the line here for where the 2,000 is. And so we're looking for that point. Looks like it's between 39 and 40. I'd say, I'm sorry, 34 and 35. Thank you. Closer to the 35. And so I might estimate that one as being about, 34.8, something like that. Your estimate does not have to be perfect, but since it's closer to the 35 than it is the 34, it should be more than 34.5. And since it's not exactly on 35, it should be less than 35.